Hello everyone, welcome back to ng.classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we will discuss quadrilaterals. Here we will discuss about each and every type of the quadrilateral in detail. And apart from that, here we will also focus on one of the type of the quadrilateral, that is parallelogram, and will discuss few theorems related to it. So let's start the discussion. So here we can see quadrilaterals family tree. You must have created your own family tree. Here we are having quadrilaterals family tree. As we can see on the screen, here head of the family member is quadrilateral. So whatever property or formula is applicable for this quadrilateral, other member of the family will also follow the same. Apart from that, other member of the family will also contain their own properties or formula. So let's discuss about each and every member of the family in detail. So let's start with the head of the family member, that is quadrilateral. Now, as we know, quadrilateral is a four-sided polygon having four sides, four vertices and four angles. Let's say we are having a quadrilateral ABCD. So A, B, C and D. As we know, sum of interior angle of a quadrilateral, that means sum of angle A, angle B, angle C and angle D is equals to 360 degree. A, B, C and D is equals to 360 degree. We already know this theorem and we have used this theorem while solving a lot of questions. Here we are going to prove this theorem. So we are going to prove angle sum property of quadrilateral. For that, we will divide our quadrilateral ABCD in two triangles. So for that, let's draw a diagonal. We can draw a diagonal AC or we can also draw a diagonal BD. So let's join vertex D with vertex B. Like this. Now here we are having two triangles, that is triangle ABD and triangle BDC. Now if we will focus on triangle ABD, we can see that sum of angle DAB plus angle ABD plus angle BDA is equals to 180 degree. From angle sum property of a triangle, that says sum of interior angle of a triangle must be 180 degree. Similarly, if we will focus on another triangle, that is triangle BCD, we can say that sum of angle BDC plus angle DCB plus angle CBE is equals to 180 degree. Again, angle sum property of triangle. Let's say the previous equation was equation 1 and now we are having equation 2. Now when we will add equation 1 with equation 2, we will get the sum of all the interior angle of our quadrilateral, right? So adding 1 and 2 will give us the sum of angle A plus angle B plus angle C plus angle D is equals to 180 degree plus 180 degree. Please note, whenever we are adding two equations, we have to add left hand side with left hand side and right hand side of the equation with right hand side of another equation. So that will give 180 plus 180. That means 360 degree. And hence we have proved the angle sum property of quadrilateral. So as we have discussed that whatever property will be applicable for head of the family member, other family member will also follow the same property. That means angle sum property, which says sum of interior angle of a quadrilateral will be equals to 360 degree. That property will be valid and will be applicable for other members of the family, which we can see on the screen. Okay. Now let's move to the first generation of the quadrilateral family, that is trapezoid, also known as trapezium. So let's discuss about trapezium in detail. So a trapezium is a quadrilateral having one pair of opposite sides as parallel to each other. So here we are having a trapezium PQRS. Here side PQ is parallel with side RS, whereas side PS and QR are not parallel with each other. The parallel sides of the trapezium is known as bases of the trapezium. So side PQ is known as base of the trapezium, and also side RS is known as base of the trapezium, whereas side PS and QR are known as legs of the trapezium. So non-parallel side of a trapezium are known as legs of the trapezium. Now since PQ is parallel to SR, so here if we will extend the line PQ, let's extend it. We will see that PS works as a transversal in between parallel line PQ and SR. So here we can say angle P plus angle S is equals to 180 degree because it's interior angle on same side of transversal. So angle P plus angle S is equals to 180, and similarly QR also acts as a transversal in between parallel line PQ and SR. So we can also say that angle Q plus angle R is equals to 180 degree. So angle Q plus angle R is equals to 180 degree. Again, interior angle on same side of transversal. Now, as we can see in the family tree, that next part or the sub part of the trapezoid is isosceles trapezoid. So, let's discuss about isosceles trapezoid. Then we will move to the other member, that is parallelogram. Now, isosceles trapezium will follow all the properties of trapezium, and apart from that, it will also have its own property. So, here we are having a trapezium ABCD. Here, side AB is parallel to side CD, and both are known as bases of the trapezium, whereas side AD and side BC are not parallel with each other. These are the properties of trapezium. Apart from that, since the name is isosceles, so we have learned about isosceles triangle where two sides of triangle are equal. Here, legs of the trapezium will be equals to each other. So, as we know, non-parallel side of a trapezium are known as legs of the trapezium. So, here AD and BC are the legs of the trapezium. So side AD will be equals to side BC. And as we know about trapezium, that is angle A plus angle D is equals to 180 degree. Similarly, angle B plus angle C is equals to 180 degree. So these properties will be applicable for isosceles trapezium as well. Now let's discuss about other family member from first generation, that is parallelogram. So here we are having a parallelogram PQRS. Here the opposite sides of the parallelogram are parallel to each other, and also opposite sides are equals to each other. So here side PQ is parallel to side RS, and also PQ and RS are of same length. Similarly, side PR is parallel to side QS, and also side PR and side QS are of same length. Apart from that, opposite angles of the parallelogram are also equals with each other. So here angle P is equals to angle S. Let's write it. So angle P is equals to angle S and angle R is equals to angle Q. Now here also, since PQ is parallel to RS, if we will extend the side PQ, let's extend it, and RS also, we will see that PR works as a transversal in between two parallel line PQ and RS. So here the sum of the angle P and R will be 180 degree. Why? Because it's interior angle on same side of transversal. So angle P plus angle R is equals to 180 degree. Similarly, angle Q plus angle S is equals to 180 degree. Now here we are having one more pair of parallel line, that is PR is also parallel with QS. So when we will extend it, we will get angle P plus angle Q is equals to 180 degree. Again, interior angle on same side. So let's write it. Similarly, angle R plus angle S is equals to 180 degree. All are interior angle on same side of transversal. So here we can say sum of adjacent angle is equals to 180 degree, or adjacent angle are supplementary with each other. And now let's get back to our quadrilaterals family tree. Here we can see the sub part of parallelogram is rectangle and rhombus. So at first we are going to discuss about rectangle. So as rectangle is a sub part of parallelogram, it will follow all the properties of parallelogram. Apart from that, rectangle will also have its own particular properties. So let's discuss about that. So here we are having a rectangle ABCD. Since opposite sides of parallelogram are parallel and equals with each other, so here also opposite side, that means AB and CD, will be parallel and are also equal in length. Similarly, the opposite sides, that means AD and BC, are parallel to each other and are also equal in length. Apart from that, each interior angle of the rectangle is of 90 degree. And just like the parallelogram, here also sum of adjacent angle will be equals to 180 degree. Now the next sub part of the parallelogram is rhombus. So let's discuss about that. So here we are having a rhombus PQRS. Since it's a sub part of parallelogram, it will follow all the properties of parallelogram. Apart from that, in a rhombus, all sides are of equal length. That means side PS, side PQ, side QR and side SR are of equal length. That means PS is equals to PQ is equals to QR is equals to RS. And also diagonal of a rhombus bisect each other at right angle. So let's draw the diagonal. So here the diagonal PR and QS bisect each other. Now bisecting means cutting each other in equal parts. So OP will be equals to OR and OS will be equals to OQ, and it bisect each other at right angles. So here we will have 90 degree. These are the specific properties of rhombus. Apart from that, it will follow all the properties of parallelogram. Now, as we can see in quadrilaterals family tree, the subpart of rectangle and rhombus is a square. So, a square will contain all the property of rectangle and rhombus. Apart from that, a square will also contain all the properties of quadrilateral and parallelogram, since a square is also subpart of quadrilateral at first and then parallelogram. So let's discuss about a square now. So here we are having a square MNOP. As we know, all sides of a square are of same length. So here side PM, MN, and O and OP are of equal length, and also each interior angle of a square are of 90 degree, just like rectangle. Apart from these, it will follow all the properties of quadrilateral, parallelogram, rectangle and rhombus. Now let's discuss about last member from first generation, that is kite. Kite is a part of quadrilateral, so it will follow all the property of quadrilateral. Now this kite is quite different from other members of the family. So let's discuss about kite. So here we are having a kite ABCD. Now in kite we are having two pairs of adjacent sides which are equal in length. So here side AB is of equal length with side BC and side AD is of equal length with side CD. Let's write it. AB is equals to BC and AD is equals to DC. Diagonal of a kite intersect each other at right angle. Be careful, it's not bisecting each other, it's just intersecting each other. Let's say the point of intersection is point O. So diagonals are intersecting each other at right angle. So here we will be having 90 degree. Here also it's 90 degree. Here as well 90 degree, and here also we will be having 90 degree. Apart from that, in a kite, angle between different length side, that means here AB and AD are of different length. So angle between that is angle A, will be equals to angle C. Please note, angle C is also between two different length sides. That means side BC is not equals to side CD. So that angle and angle A will be equals to each other. Angle between different length side are congruent. In a kite, longer diagonal bisect is smaller diagonal. So here as we can see, BD is a longer diagonal and AC is a smaller diagonal. So longer diagonal, that means BD, is bisecting the smaller diagonal AC. That means AO is equals to OC. Be careful here, both the diagonals are not bisecting each other. And in a kite, longer diagonal, that means BD, also works as an angle bisector of top and bottom angle. So longer diagonal BD or the line BD is bisecting angle B. That means this angle will be equals to this angle. And also it is bisecting the bottom angle D. So this angle will be equals to this angle. So these are few specific properties of kite. And now let's prove few theorems related to parallelogram. So our first theorem says a diagonal of a parallelogram divides it into two congruent triangles. Let's say we are having a parallelogram ABCD. Here we are having a diagonal BD. We can also start with diagonal AC. So we have to prove that diagonal BD is dividing the parallelogram into two congruent triangle. Here we can see two triangles, that means triangle ABD and triangle CDB. Let's write it. So we are having triangle ABD over here and triangle CDB. Now we know that in a parallelogram, side AB is parallel to side CD and side AD is parallel to side BC. So let's focus on parallel side AB and CD. Let's remove the other side for a while. From here we can see that angle ABD is equals to angle CDB, as both are pair of alternate interior angles. So let's write it that angle ABD is equals to angle CDB. Now, if we will focus on our triangles, we can see that side BD is the common side in both the triangle. So let's write it. Now, if we will focus on another pair of parallel lines, that means AD and BC, we will get another pair of angles which will be equals to each other. So let's see it in the figure. Let's remove the side AB and CD for a while, and we are going to focus on parallel line AD and BC, where BD is the transversal. Here we can say that angle ADB is equals to angle CBD. Again, alternate interior angle. Let's write it. Angle ADB is equals to angle CBD. Pair of alternate interior angle. Now here we got the sequence of angle, side, angle. Please check it in the figure also. So we can say that triangle ABD is congruent with triangle CDB by angle side angle congruent rule. Please check the sequence as well. That means AB must be corresponding side with CD. PD must be corresponding side with BD or DB, and AD must be corresponding side with CB. Hence, we have proved that a diagonal of a parallelogram divides it into two congruent triangles. Now let's see the other theorem. So the next theorem says in a parallelogram, opposite sides are equal. So let's say we are having same parallelogram ABCD, and now only we have proved that in this parallelogram triangle ABD is congruent with triangle CDB, and since these two triangles are congruent with each other, hence we can say that AB is equals to CD, and also AD is equals to BC, because both are corresponding part of congruent triangle, right? By CPCT, which means corresponding part of congruent triangle. And hence we are done with this proof. So to prove this theorem that opposite side of a parallelogram are equal, at first we have to prove that diagonal of a parallelogram divide it into two congruent triangle, and after that we can say that corresponding sides of a congruent triangle will be equals to each other. So hence we are done with the proof. Let's see our next theorem. So our next theorem says if each pair of opposite side of quadrilateral is equal, then it's a parallelogram. So we are having a quadrilateral ABCD over here. We know that in this quadrilateral, side AB is equals to side CD and side AD is equals to side BC, as given in the theorem that each pair of opposite sides of a quadrilateral is equal. With this information, we have to prove that our quadrilateral is a parallelogram. Let's prove it. Here we have also drawn a diagonal of the quadrilateral. So we have drawn a diagonal BD in our quadrilateral ABCD. Due to that, we got two triangles over here, that is triangle ADB and triangle CDB. So we can see two triangles, that is triangle ABD and triangle CDB. Now, if we will focus on these two triangles, we can see that side AB is equals to side CD, already given in the theorem. We can also see that side AD of triangle ABD is equals to side BC of the other triangle, that is also given in the theorem. And we can see that BD acts as a common side in both the triangles. Let's write it. Now from here we can say that triangle ABD is congruent with triangle CDB by side congruent rule. So ABD is congruent with triangle CDB by side congruent rule. Now, since these two triangles are congruent with each other, their corresponding angles and corresponding sides will also be equals to each other. So, angle DAB will be equals to angle DCB. Similarly, angle ABD is equals to angle CDB, and angle ADB is equals to angle CBD. So these are pair of corresponding angles which will be equal. Now since angle ABD, this green angle will be equals to angle CDB, another green angle, can you see it in the figure? We can say that AB will be parallel to CD, as these two are alternate interior angle. Whenever two lines are cutted by a transversal and alternate interior angles are equals to each other, then those two lines must be parallel to each other, right? So here this equality gives that AB must be parallel to CD. And since angle ADB, that is this purple angle, is equals to angle CBD, hence we can say that AD must be parallel to BC. From here we got that we were having a quadrilateral ABCD where opposite sides were equal in length. We have also proved that opposite sides are parallel to each other, and we know this is the definition of parallelogram. That means opposite sides must be parallel and equals to each other. Hence the quadrilateral ABCD will be parallelogram. Therefore, ABCD is a parallelogram. Now let's move to the next theorem. So our next theorem says in a parallelogram, opposite angles are equal. So here we are having a parallelogram ABCD. We have to prove here that angle A is equals to angle C. That means opposite angles are equal with each other. Similarly, we also have to prove angle B is equals to angle D. This is what we have to prove. Now, since we are having a parallelogram ABCD, we can say AB must be parallel to CD, and we can also say that AD must be parallel to BC. Here we can write, since AB and CD are parallel with each other, hence angle BCA must be equals to angle BAC, right? Because these two are pair of alternate interior angle. So let's write it, angle BCA is equals to angle BAC, alternate interior angle. Now, since AD is also parallel to BC, so we can say that angle BCA is equals to angle DAC. Again, pair of alternate interior angle. So let's write it. Angle BCA is equals to angle DAC, alternate interior angle. Now, let's say this one is equation 2 and the previous one was equation 1. Now let's add both the equation. So whenever we are adding two equations, we must add left hand side with left hand side and right hand side of one of the equation with right hand side of another equation. So let's add BCA with BCA. Angle DCA plus angle BCA is equals to angle BAC plus angle DAC. Now when we will focus on angle DCA plus BCA, we will get the complete angle C. Can you see this purple angle and this green angle is making the complete angle C? So here we can write angle C is equals to angle BAC plus angle DAC. When we will look at both the angle, this two angle is making the complete angle A. That is, replace it by A. Hence we got angle C is equals to angle A. That means pair of opposite angle are equals to each other. Similarly, we can also prove that angle B is equals to angle D. When we will take the diagonal BD like this, then with the help of parallel line concept only, we will be able to prove that angle B is equals to angle D. So here we can write similarly angle B is equals to angle D, and hence we are done with the proof. We were having a parallelogram ABCD and we have proved that opposite angles are equals to each other. Now let's see the next theorem. So our next theorem says if in a quadrilateral each pair of opposite angles is equal, then it's a parallelogram. So here we are having a quadrilateral ABCD. Here it says that opposite angles are equals to each other. This one is just the reverse of the previous theorem. It is given that angle A is equals to angle C and angle B is equals to angle D. And we have to prove that ABCD is a parallelogram. Now, since we are having a quadrilateral ABCD, can we write angle A plus angle B plus angle C plus angle D is equals to 360 degree? Angle sum property of quadrilateral, which says sum of interior angle of a quadrilateral must be 360 degree. Here at the place of angle C, can I write angle A? Because angle A is equals to angle C, which is already given in the theorem. And also, can we write angle B at the place of angle D? Because both are same, right? Let's write it. Is equals to 360 degree. So from here we will get twice of angle A plus twice of angle B is equals to 360 degree, which will give us angle A plus angle B is equals to 180 degree. Similarly, we can also prove that angle C plus angle D is equals to 180 degree just by replacing A and B with C and D. We will also get here angle A plus angle D is equals to 180 degree, and also angle B plus angle C is equals to 180 degree. Now, if we will focus on line AB and CD, here we can see BC works like a transversal. So, for line AB and CD, BC works as transversal. And we also know that angle B plus angle C is equals to 180 degree. So, let's write it here. So these two angles, that is angle B and angle C, are interior angle on same side of transversal, and its sum is 180 degree. Hence from here we can say that AB must be parallel to CD. Similarly, if we will focus on line AD and BC, so for line AD and BC, AB works as a transversal. And we also know that angle A plus angle B is equals to 180 degrees. So let's copy paste it. Now from here we can say that AD must be parallel to BC, since sum of interior angle on same side of transversal is equals to 180 degree. And here we can see opposite sides of quadrilateral are parallel to each other. So we know whenever in a quadrilateral opposite sides are parallel to each other, then it must be a parallelogram. Hence we can say ABCD is a parallelogram. Therefore ABCD is a parallelogram. And hence we are done with the proof. Now let's see our next theorem. So our next theorem says the diagonals of a parallelogram bisect each other. So here we know we are having a parallelogram ABCD, and we have to show that the diagonal of this parallelogram is bisecting each other. That means diagonal BD is bisecting diagonal AC. So it is given that ABCD is a parallelogram and we have to prove that both the diagonals are bisecting each other. That means AO must be equals to OC and OB must be equals to OD, right? So AO is equals to OC and OD is equals to OB. That's what we have to prove here. Now, since we know it's a parallelogram ABCD, so AB must be parallel to CD. And since AB is parallel to CD and BD, the diagonal BD works as a transversal, so can we say that angle ABO must be equals to angle ODC? Because these two are pair of alternate interior angle, right? Let's write it, that angle ABO will be equals to angle ODC, alternate interior angle. Let's say this is equation 1. Similarly, since AB is parallel to CD, we can say that angle OAB, the green angle, can you see it, will be equals to angle OCD, other green angle, again pair of alternate interior angle. So angle OAB must be equals to angle OCD, again alternate interior angle. Let's say this one is equation number 2. Now let's focus on triangle AOB and triangle COD. So triangle AOB and triangle COD. We can see here that in triangle AOB, angle OAB is equals to angle OCD. From equation 2, we can also see that side AB is equals to side CD, since we are having a parallelogram ABCD whose opposite sides must be parallel and equals to each other. So let's write it. Side AB is equals to side CD. It is already given in the theorem. And also we can see in triangle AOB, angle ABO is equals to angle ODC from equation 1. And here we got the sequence of angle, side, angle. Can you see it? This one is the angle, then side, then again angle. You can check it in the figure also. So we can say that triangle AOB is congruent with triangle COD. So triangle AOB is congruent with triangle COD by angle side angle congruent rule. And since these two triangles are congruent with each other, hence we can say that side AO must be equals to side OC, because these two are corresponding part of congruent triangle. And also we can say that side OB must be equals to side OD. So side AO must be equals to side OC and side OD must be equals to side OB by CPCT. And hence we proved that diagonal of a parallelogram bisect each other. Now let's see our next theorem. So our next theorem says if the diagonal of a quadrilateral bisect each other, then it's a parallelogram. It is just the converse of the previous theorem. Here it says if we are having a quadrilateral ABCD and here the diagonal of the quadrilateral is bisecting each other, then it's a parallelogram. So it's given that AO is equals to OC. That's the meaning of diagonal bisecting each other, and OD must be equals to OB. And we have to show that ABCD is a parallelogram. Now here we are having four triangles. Can you see? Triangle AOB, triangle COD, triangle AOD and triangle BOC. So we can take any two triangles. Let's say triangle AOB and triangle COD. Or we can also start with triangle AOD and triangle BOC. Let's take triangle AOB and triangle COD. In this two triangle, we already know that OA is equals to OC. It is given already. We also know that angle AOB will be equals to angle COD. It's a pair of vertically opposite angle. So let's write it. Angle AOB must be equals to angle COD. Vertically opposite angle. And we also know that OB must be equals to OD. That is also given in the theorem only. Now we got the sequence of side, angle, side. That means side included angle and then other side. You can check it in the figure also. So hence we can say that triangle AOB must be congruent with triangle COD by side angle side congruent rule. Now since these two triangles are congruent with each other, their corresponding part will also be equals to each other. So from here we can say that angle OAB must be equals to angle OCD and angle OBA must be equals to angle ODC by CPCT. Now since angle OAB, that means this angle, is equals to angle OCD, and we are having two lines AB and CD where BD acts as a transversal, and these two angles are equals to each other. Hence we can say that AB must be parallel to CD. So let's write it. For line AB and CD, AC is transversal and we also know that angle OAB is equals to angle OCD, therefore which acts as a pair of alternate interior angle. Hence we can say therefore AB must be parallel to CD, right? We have proved that AB is parallel to CD. Similarly, if we will take triangle AOD and triangle COB, we will find that these two triangles are also congruent with each other. And from here, we will be able to prove that AD is parallel to BC. Once we will prove that AD is also parallel to BC, we can say this quadrilateral is a parallelogram. So here directly we can write similarly AD is parallel to BC since triangle AOD must be congruent with triangle COB, and therefore ABCD is a parallelogram, because if opposite sides of a quadrilateral are parallel to each other, then it must be a parallelogram, and hence we are done with the proof. Now let's see our last theorem related to parallelogram. So the theorem says quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. So we are having a quadrilateral ABCD over here, and we have to show that this quadrilateral is a parallelogram. One more information is given in the theorem, that is a pair of opposite sides is equal. A pair, that means one of the pair of opposite sides are parallel and equals to each other. What we have to prove here, that other pair is also parallel and equal with each other. Once we will prove that, we can say the quadrilateral ABCD is a parallelogram. So for that, let's draw the diagonal AC. Now, here it is already given that AB is parallel to CD and also AB is equals to CD, and we have to prove that AD is also parallel to BC and both are equal with each other. Now let's focus on triangle BAC and DCA. So triangle BAC and triangle DCA. In this two triangle, we know that BA or AB is equals to CD. That is already given in the theorem. We also know that since AB is parallel to CD, hence angle DCA will be equals to angle BAC, pair of alternate interior angle. So let's write it. Angle BAC is equals to angle DCA, since AB is parallel to CD and these two are pair of alternate interior angle. And we can also see here that side CA or AC is the common side in both the triangle, right? And now we got the sequence of side angle, that is included angle, and then again side. You can check it in the figure also. And hence we can say that triangle BAC must be congruent with triangle DCA by side angle side congruent rule. And since these two triangles are congruent with each other, here we can say their corresponding paths will also be equals to each other. That means side AB must be equals to side CD, side AD must be equals to side BC, and also angle DAC is equals to angle BCA. This angle will be equals to this angle, and angle ADC must be equals to angle ABC by CPCT. Now let's see the figure carefully. Here we can see these two green angles are equal with each other. So can we say AD must be parallel to BC? Because these two works like a alternate interior angle. And if alternate interior angle are equals with each other, then two lines AD and BC cutted by a transversal AC must be parallel to each other. So for line AD and BC, where AC is transversal, we can say angle DAC is equals to angle BCA, this one. Therefore, AD must be parallel to BC. We have proved that AD is parallel to BC, and we have already written here that AD is equals to BC because these two are corresponding side of congruent triangle. So AD is also equals to BC by CPCT, and hence we can say if a pair of opposite side of a quadrilateral is equal and parallel, then the other pair will also be parallel and equals to each other, and the quadrilateral must be a parallelogram. So we can say therefore ABCD is a parallelogram. Now let's solve one question from exercise. So our question says in a parallelogram ABCD, here we are having the figure as well. 2 points P and Q are taken on diagonal BD such that DP is equals to BQ. So here DP is equals to BQ, which is already given in the question. Show that triangle APD is congruent with triangle CQB. So let's do part 1 at first. So here our question is talking about triangle APD and triangle CQB. Can you see this two triangle APD and CQB, the red colored triangle? So triangle APD and triangle CQB. We have to show that these two triangles are congruent with each other. Now, since ABCD is a parallelogram, here opposite sides must be parallel. and equals to each other. So we can say that side AD must be equals to side BC. Let's write it. Opposite sides of parallelogram are equal with each other. After that, we can say that angle ADP must be equals to angle CBQ, pair of alternate interior angle, since AD is parallel to BC. So let's write it. Angle ADP is equals to angle CBQ. Since AD is parallel to BC and these two are pair of alternate interior angle. And it is already given in the question that DP is equals to BQ. So let's write it. DP is equals to BQ, already given. Hence we got the sequence of side angle, that means included angle, and then again side. And hence we can say that triangle APD must be congruent with triangle CQB by side angle side congruent rule. So we have shown the first part. Let's move to the next part. So the next part says AP is equals to CQ. Now, if we will focus on this two triangle, that is APD and CQB, we can say that AP must be equals to CQ because these two are corresponding part of congruent triangle. So from here we can do part 2 also, that is AP must be equals to CQ by CPCT. Now let's see the next part. So the next part says show that triangle AQB is congruent with triangle CPD. So let's focus on triangle AQB and triangle CPD. Can you see blue colored triangle? Yes. So here in triangle AQB and triangle CPD, we can say that side AB must be equals to side CD, as ABCD is a parallelogram and opposite sides of parallelogram are equals to each other. Let's write it. Opposite sides of parallelogram are equal with each other. Now we can say that angle ABQ, that means this angle, must be equals to angle CDP. Again, AB is parallel to CD and these two are pair of alternate interior angle. So angle ABQ is equals to angle CDP. Since AB is parallel to CD and we are having pair of alternate interior angle. And it is also given in the question that DP is equals to PQ. That means side BQ is equals to side DP. So we can write it here. BQ is equals to DP. That is already given in the question. And hence we got the sequence of side, included angle, and then side. And hence we can say that triangle AQB must be congruent with triangle CPD. by side angle side congruent rule. So we are done with part 3. Let's move to part 4. So part 4 says show that AQ is equals to CP. So from here only we can say AQ is equals to CP because these two are corresponding part of congruent triangle AQB and CPD. So we are done with part 4 as well. Let's move to part 5. So part 5 says show that APCQ is a parallelogram. Now here we have to show that green quadrilateral is a parallelogram. That is APCQ is a parallelogram. Now only we have proved that AP is equals to CQ. That is part 2. And we have also proved that AQ is equals to CP. These two we have proved already. Now, since AP is equals to CQ and AQ is equals to CP, these two are same and these two are of equal length. Therefore, APCQ is a parallelogram. And hence we are done with all the parts. Now let's see our next theorem. So our next theorem is called midpoint theorem. And here the theorem says the line segment joining the midpoint of two sides of a triangle is parallel to the third side and its measure is half of the measure of the third side. So here we are having a triangle ABC and it is already given that D is the midpoint of the side AB as well as E is the midpoint of the side AC. That means it is given that AD is equals to BD and AE is equals to EC. So to prove that, here we need to do one construction. So let's do the construction. Let's extend the side DE. Up to point F such that DE is equals to EF. And let's join point C with point F. Now here we got a triangle, that is triangle CEF. Before moving ahead, we must know that we have to prove that DE is parallel to BC and also DE is equals to half of the side BC. Let's write it. To prove that DE is parallel to BC and DE is equals to half of the side BC. Now let's focus on triangle ADE and triangle CFE. So we are having two triangles, that is triangle ADE and triangle CFE. Here side AE is equals to side CE, which is already given in the theorem, as E is the midpoint of side AC. Now here we can say that angle AED must be equals to angle CEF. When we will focus on AC and DF, we can see both the lines are intersecting each other and hence we will get vertically opposite angle which will be equals to each other. So angle AED is equals to angle CEF. That is vertically opposite angle. And we have done the construction in such a way that DE is equals to EF. So let's write it. DE is equals to EF by construction. And if we will see carefully, we got the sequence of side, included angle, and then side. Hence, triangle ADE is congruent with triangle CFE. Therefore, triangle ADE is congruent with triangle CFE by side angle side congruent rule. Now, since these two triangles are congruent with each other, their corresponding parts must be equals to each other. So, let's write the corresponding part of these two triangles. So, we can write side AD must be equals to side CF or FC. Side DE must be equals to side FE. And side AE must be equals to side CE. Apart from that, angles will also be equals to each other. So, angle DAE is equals to angle ECF. Angle AED is equals to angle CEF. And angle EDA is equals to angle EFC, all by CPCT. That means corresponding part of congruent triangle must be equals to each other. Now from here, if we will focus on side AB and side FC, can you see these two sides? So we can write for line AB and CF, AC is transversal and we also know that angle DAE is equals to angle ECF. Let's write it here. Angle DAE is equals to angle ECF for the line AB and CF. If AC is a transversal, then angle A and angle C is alternate interior angle with each other and both are equals to each other. Hence, we can say, therefore, AB must be parallel to CF. So, let's write it. We know that AB is parallel to CF. Hence, DB must be parallel to CF. And we also know that AD is equals to BD, already given in the theorem. And from corresponding part of congruent triangle, we have also got that AD is equals to CF. By CPCT, we have already got it from equation 1 and equation 2. We can say since AD is same as BD and AD is also same as CF, therefore, from 1 and 2, BD is equals to CF. Now, we got side BD and side CF are equals with each other. We have also proved that side BD and side CF are parallel to each other. Hence, BDCF is a parallelogram. Can you see the green colored parallelogram over here? Yes, that's a parallelogram. BDFC is a parallelogram. And since we have proved that it's a parallelogram, its opposite side will be parallel and will be equals to each other. So from here we can write that side DF must be parallel to side BC, which implies that side DE must be parallel to side BC. And also from here we can write that DF is equals to BC. Both sides must be equal in length. Now this DF is the combination of side DE and side EF, that is BC. And since DE and EF are of same length, hence at the place of EF we can write DE. That means 2 times DE is equals to BC. Twice of DE is equals to BC, and that will give us DE is equals to half of BC. That's what we wanted to prove, that DE is parallel to BC and DE must be equals to half of side BC. So we have proved DE is parallel to BC and DE is equals to half of BC. And hence we are done with the proof. Now let's see our next theorem. So the next midpoint theorem says the line drawn through the midpoint of one of the side of a triangle parallel to another side bisect the third side. So here it is already given that we are having a triangle ABC where D is the midpoint of AB. That means AD is equals to BD. See carefully, line drawn through the midpoint of one of the side of a triangle parallel to another side. That means it is also given that line drawn through D, that means DE, is parallel to BC. Bisect the third side. That means we have to prove that AE must be equals to EC. Now here also we have done the construction. We have drawn CF in such a way that CF or FC must be parallel to AB. We have drawn CF parallel to AB. Now since CF is parallel to AB, we can also say that CF must be parallel to BD. Since parts of two parallel lines must be parallel with each other, so from here we can say that CF must be parallel to BD. And we have also drawn CF in such a way that the length of CF must be equals to the length of BD. Hence, we can say DBCF is a parallelogram. So from here, we can say that DBCF is a parallelogram. And since it's a parallelogram, its opposite side must be parallel and equals to each other. So, side DF must be parallel to side BC and DF must be equals to BC. Now, let's focus on triangle ADE and triangle CFE. Here we can say that angle AED must be equals to angle CEF, as these two are vertically opposite angle. Here we can also say that angle ADE must be equals to angle CFE, as these two are pair of alternate interior angle since AB is parallel to CF. So angle ADE is equals to angle CFE, alternate interior angle. And since side CF is equals to side BD, CF is equals to BD, and we also know that BD and AD are of same length. Since D is the midpoint of side AB, hence we can say that side CF is equals to side AD. Now from here we got the sequence of angle, again angle, and then side. That means triangle ADE and triangle CFE must be congruent with each other. Triangle ADE is congruent with triangle CFE. by angle side congruent rule. And since these two triangles are congruent with each other, hence we can say their corresponding parts will be equals to each other. And from here we can say that side AE of triangle ADE must be equals to side EC of triangle CEF. Therefore, side AE is equals to side EC by CPCT. And hence we are done with the proof. Now let's prove one theorem from exercise. So here our theorem says in a parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. So let's write it whatever is given in the theorem. So it's given that ABCD is a parallelogram and it is also given that E and F are midpoint of side AB and CD respectively. So if E is the midpoint of side AB, then we can write that AE must be equals to EB, and if F is the midpoint of the side DC, then we can write DF must be equals to FC. Now the theorem says so that the line segment AF and EC trisect the diagonal BD. That means we have to prove BP is equals to PQ is equals to QB. That's what we have to prove it, that all the three parts, this part and this part are of same length. Then only we can say the line BD is getting trisected. So since ABCD is a parallelogram, here AB must be parallel to CD. And we can say that AE must be parallel to FC, because parts of a parallel line must be parallel with each other. So since AB is parallel to CD, then AE must be parallel to FC. So we can write AB is equals to CD. This is one of the equation we are having. Now whenever we are having one equation, we know we can add, subtract, multiply or divide both sides by same number. And this way we are not disturbing the equilibrium of the equation. So we can divide both sides of equation 1 by 2. We can write it as AB by 2 is equals to CD by 2. Dividing both sides by 2. Now AB by 2, that means AE or BE, since E is the midpoint of side AB. Let's write it. This is AE, and CD by 2, we can write it as CF, since F is the midpoint of side CD. So from here we got that side AE is parallel to side CF. And also we have got that side AE is equals to side CF. Hence we can say that AECF is a parallelogram. So therefore AECF is a parallelogram. And since AECF is a parallelogram, its opposite side must be parallel and equals to each other. So we can say that AF must be parallel to CE. Let's write it properly. So here AECF is a parallelogram. Where AF must be parallel to EC. Since we know parts of a parallel line must be parallel with each other, so here we can say that PF, which is a part of a line AF, must be parallel with QC, which is a part of a line EC, right? Similarly, we can also say that AP must be parallel to EQ. Now let's focus on triangle DQC. So in triangle DQC, we can see that F is the midpoint of side DC, and we also know that PF is parallel to side QC. Here we can use previous theorem which says line drawn through midpoint of one of the side of a triangle parallel to the another side must bisect the third side. So here we can say line FP will bisect side DQ of triangle DQC. Since FP is bisecting the side DQ, hence we can write that DP must be equals to PQ. Let's say this one is equation 2. Now let's focus on triangle APB. So triangle APB we are having here, and here also we can see that E is the midpoint of side AB. And again we can use the same theorem. So we can say line EQ is bisecting side PB, and therefore PQ is equals to QB. Let's say this one is equation number 3. Let's write the previous theorem, that line drawn through midpoint one side of a triangle parallel to another side will bisect the third side. And now from equation 2 and equation 3, we can say that DP is equals to PQ and PQ is equals to QB. That means all three are equals with each other. So right from equation 2 and equation 3, DP is equals to PQ and PQ is equals to QB. And from here we can see that line BD is getting trisected. That's what we wanted to prove here. And hence we are done with our proof. So hence proved. And this was the last question of today's topic. I hope you have understood the whole concept on quadrilaterals. Stay tuned for the next video. Thank you.